One day, our sun will die. It will not explode. It will not shatter the sky with light. It will simply grow tired. We built our entire existence around this star. Every sunrise, every harvest, every heartbeat on Earth is powered by a single burning sphere that we never once questioned. We assumed it was eternal. It is not. Right now, at this very moment, the sun is burning through 600 million tons of hydrogen every single second. It has been doing this for 4.6 billion years without stopping. But the fuel is running out. Deep inside the core, where temperatures reach 15 million degrees, hydrogen atoms are being crushed together so violently that they fuse into helium. This is the engine. This is what holds the sun together. Without it, gravity wins. And gravity always wins. The sun is not a ball of fire. It is a war. A constant battle between the outward pressure of nuclear fusion and the inward pull of its own mass. For billions of years, this war has been a perfect draw. But the balance is shifting. As the hydrogen runs out, the core will begin to shrink. And as it shrinks, it heats up. The outer layers, no longer held in check, will begin to expand. Our quiet little star will start to swell. At first, it will grow slowly. The sky on Earth will get brighter. The oceans will warm. The ice caps will vanish. But this is just the beginning. Over the next few 100 million years, the sun will inflate into something unrecognizable. It will become a red giant, a bloated, dying monster hundreds of times its current size. Its surface will cool from white-hot to a deep, angry red, but the sheer size of it will make it thousands of times more luminous. It will swallow Mercury whole. The closest planet, the scorched little rock that has orbited faithfully for billions of years, will simply vanish beneath the surface of the expanding star. Venus will be next. Its thick atmosphere, hot enough to melt lead, will be stripped away in seconds. The planet itself will spiral inward, dragged by tidal forces, and dissolve into the plasma. And then the fire will reach us. The oceans will be the first to go. They will not gradually evaporate. They will boil violently, explosively, sending massive columns of superheated steam into a sky that is already turning red. The rivers will vanish. The lakes will vanish. Every drop of water on the surface of the Earth will be ripped into the atmosphere and then stripped away into space. The mountains will melt. Not crumble, not erode, melt. The rock itself will liquefy, flowing downhill in rivers of glowing lava. The surface temperature will climb past 1,000 degrees, past 2,000 degrees, until the entire crust is a sea of molten stone, glowing orange against a blood-red sky. The atmosphere will be peeled away layer by layer, first the oxygen, then the nitrogen, torn from the planet by the solar wind of a star that no longer knows restraint. Every city, every forest, every footprint we ever left behind will be erased. Not destroyed, erased, as if none of it ever existed. And the sun will not care.
It cannot care. It is not alive. It is a process. A slow, mechanical, gravitational collapse dressed in light. It will keep expanding, glowing in a dim, dying red, a sphere so enormous that if you placed it where our sun is today, its surface would reach beyond the orbit of Mars. This is what our star becomes. Not a god, a corpse that has not yet finished falling. But even a red giant cannot last forever. The core, now burning helium into carbon and oxygen, will eventually exhaust that fuel too. And when it does, the star will shudder. The outer layers, barely held together by a thread of gravity, will be expelled into space. Not violently like a supernova. Our sun is too small for that kind of death. Instead, it will breathe out, a slow, ghostly exhale.
The expelled gas will form a planetary nebula, a shell of glowing color expanding outward in every direction. Blues, greens, pinks, teals. Some of the most beautiful structures in the universe are the corpses of stars like ours. And at the center of this colorful tomb, a tiny remnant will remain, a white dwarf. The core of the sun, compressed into an object no larger than the Earth, but carrying the mass of an entire star. A single teaspoon of its material would weigh 15 tons. It will glow with residual heat, a fading ember in the dark, but it will produce no new energy.
No fusion, no fire. Just the slow, patient release of heat accumulated over 10 billion years of burning. And it will cool. For trillions of years, longer than the current age of the universe, the white dwarf will slowly fade, from white to yellow, from yellow to orange, from orange to red, and finally to black. A black dwarf, an invisible, cold, dead sphere drifting through the darkness. No one has ever seen one. The universe is not old enough for any to exist yet. Our sun will be among the first. Without the sun, the solar system will unravel. Mars will drift. Jupiter and Saturn, still massive, will pull the remaining debris into chaotic new orbits. The asteroid belt will scatter. The Kuiper belt will dissolve. The Oort cloud, that vast sphere of frozen comets at the edge of our system, will slowly evaporate into interstellar space, comet by comet, over millions of years. The solar system will not die in a moment. It will fade. Like a song no one remembers the words to. But here is what makes this story not a tragedy, but a transformation. The gas that the sun exhales in its final breath, the planetary nebula, carries with it every element the star forged during its lifetime. Carbon, oxygen, nitrogen, the building blocks of life itself. These elements will drift through space for millions of years until gravity gathers them again. They will collapse into a new cloud. That cloud will form a new star, and around that star, new planets. And on one of those planets, in a billion years or a trillion, something might open its eyes and look up at its own sun, and wonder if it too will last forever. We are not separate from this cycle. We are made of it. Every atom in your body was forged in a star that died before ours was born. The calcium in your bones, the iron in your blood, the oxygen in your lungs, all of it was cooked inside a stellar furnace and scattered into space by a death just like the one that awaits our sun. We are the universe looking at itself, and one day, the universe will recycle us back. The sun will die. The earth will be erased. But the atoms that made us will go on. They will become part of something new, something we will never see.